All right, in this mole conversion video, you're going to learn how to go between moles and mass and moles and volume. All right, so let's start with going back and forth between how many moles and a mass. And the mass is going to be always, or you're going to want the mass in grams. So if it's in anything other than grams, you're going to want to make sure that you put it into grams before you start making these conversions. So our conversion factors are going to be in the form of a number of grams per mole or a number of moles per grams. And these conversion factors are called molar masses. And I taught you how to write molar masses in a different video, so you will need to know how to get or obtain molar masses to be able to make these conversions. These conversions will also be a single step conversion. You will be going directly from moles to mass, just one step. As with any one-step conversion, you're going to be using my little format here, where the number that you're given, you're going to multiply it by a conversion factor. So this will be your conversion factor. And your conversion factor will be set up with the units that are the same units on the given and then the units you want on the top. All right, so let's do an example. So an example would be, how many moles would 22.3 grams of CaCO3 be? So we are given grams of CaCO3 and we are asked to find moles. So we need to set it up with the given first, and then we're going to multiply by a ratio with grams on the bottom so that those cancel, and moles on the top because that's what we want. And then from here we need to fill in our conversion factor. So we're going to need the molar mass of calcium carbonate. So the molar mass of calcium carbonate, you can add that up from the periodic table, equals 100.086 grams. So when we work this out, we take 22.3 and we divide by 100.086, and you should get 0.223 moles of calcium carbonate. All right, let's do another example. So in this question, we're asked to find out how much 1.4 moles of magnesium nitrate would weigh. So what we were given is this, that we have 1.4 moles of magnesium nitrate. What we're asked to find is a mass or a weight. So that's what we want. And remember, it's going to be in grams. So if I set it up the way that our little template tells us to, our given, our 1.4 moles of magnesium nitrate, would go first, and then we'll multiply by our conversion factor, which is the molar mass for magnesium nitrate. I just added it up from the periodic table. So 148 grams goes on top because that's what we're trying to get to, and then the moles go on the bottom because it's the same unit that's on our given. So moles will cancel, and we would end up with 207.6 grams of magnesium nitrate. So 1.4 moles of magnesium nitrate would weigh 207.6 grams. So why don't you try and see if you can do a couple problems. So pause it and work through both of these and then see if you get the right answer. So here's what the first one would look like. So you should get 4.547 moles of K2O. And on the second one, you should get 736 grams of NO2, or 740 if you're rounding to sig figs. All right, so now we're going to do another one-step conversion, this time between moles and volume. So something you need to know, any gas, 1 mole of any gas at what we call standard temperature and pressure, which is 0 degrees Celsius and 1 atmosphere of pressure, will occupy 22.4 liters of volume. So any gas at this temperature and this pressure will have the same volume, 22.4 liters. So it's important that we note that these only work for gases. So solids and liquids, their volumes wouldn't change with temperature. They have a fixed volume. So the conversion factors you're going to use are 1 mole for every 22.4 liters or 22.4 liters per 1 mole. All right, so we're going to use the same template that we used for the other one-step conversions. And our example is, how many liters would 2.2 moles of H2 gas occupy? So we're given that we have 2.2 moles of H2 gas, and what we're asked to find is liters. So this is what we want. So let me move this up. So when we set this up, again, you always set up with what you were given first, and then you're going to multiply it by your conversion factor. In this case, we're going to put liters on the top because that's what we want, and moles on the bottom because that's the unit that was on the given. So moles will cancel, and we'll be left with liters. 49 liters in this case. So we have 49 liters of H2 gas in 2.2 moles. All right, let's do another example. So in this example, I'm asking for the number of moles in 14.3 liters of neon gas. So here is what I am given, and here's what I'm asked to find. So if we use our template, we would put 14.3 liters first of neon, and then we are going to set it up with the mole on top because it's what we want, it's what we've been asked to find, and liters on the bottom because it's the same unit that's on my given liters. So liters would cancel, and I would be left with moles as my unit, and I would get 0.638 moles of neon. All right, so why don't you give it a try? Write these down, pause, work them out, and then unpause and see if you get the right answer. All right, so the first one, you should get 16.8 liters of SO2 gas. And on the last one, you should get 20.4 moles of helium. So that brings us to the end of this tutorial on our single-step mole conversions between mole and mass and mole and volume.